In this lesson, I'm going to take a look at another reason that it was a good idea to declare and define the star operator multiplication for a fraction as a non-member and the star equal as a member. So let's see what's going on here. Okay, I'm going to create two fractions, f 3/4 and g a default, and I want to assign to g f times 5 or 5 times f. Now this seems like a natural thing to do. Multiply a fraction times an integer, and it should be able to work. Now the problem or the consideration is we've defined multiplication for a fraction times a fraction, and 5 is not a fraction, it's an integer. So let's take a look at our definition. For the star operator, we notice it takes a fraction and a fraction. So what we're trying to do is we're trying to call this function star operator with a fraction and an integer, meaning f is going to go in for the left-hand side and 5 in for the right-hand side. The problem is 5 is not a fraction, right? It's got to be a fraction. Okay, we can solve the problem if we have a constructor for the fraction class that takes a single integer value that is the same as this type here, a single instance of that integer value, and it turns this thing into a fraction. The numerator is going to be that value of n. The denominator will be 1. So 5 is going to get converted to 5 over 1. This is called a constructor for automatic conversion. It's a constructor that takes a single value of a particular type and builds an object of the user-defined type. What happens when you call this operator, there's a star underneath there, call this operator, the compiler recognizes that the 5 that is supposed to be going in for this parameter can be automatically converted to a fraction type object using this constructor here. So what happens then? The constructor is called, a temporary object is created, its numerator is 5, its denominator is 1, so I've created this temporary object. F then is multiplied in, and the result is assigned to g in main. What about the second case? Same thing happens. The operator star is calling for a fraction. This is an integer. The compiler recognizes that, calls the constructor, and changes 5 to a fraction, and then it can carry out the multiplication. Well, let's look at an alternative. Here we have a different star operator definition. It returns a fraction, its name is operator star, and it takes an integer as an argument. Its parameter is an integer. So I've overloaded the operator even one more time. Is it good? And by the way, I've put my old definition for the operator star down here below so we can take a look at what's happening. Well, in this case, yes. The 5 goes in here for right-hand side. F is the calling object, and I get what I want. Now the problem occurs when I have this situation. Can we solve this with another overload of the operator star? And the answer is no, because 5 is on the left-hand side of the operator. It would have to be the calling object, and that's not possible. It cannot be calling object for a fraction class function. And so this alternative is really no good. This one works every time. This can be changed from an integer to a fraction. This can be changed from an integer to a fraction. And I think we've got a really nice definition, and we should not consider this overload. Let's cross it out even more. Okay, and that's overloading operators.